Welcome, everyone. What a glorious day it is here today, and I am happy to be presenting another video for you. I'm hoping these videos are helping you. So we are going through Chapter 2 of Zybooks, and we're talking about constant variables right now. So one of the things I always stress out to all of my students in all my classes is that never use a literal value when you can use a constant, and never to make a chance that something could change. For instance, we all know that pi is 3.14159, something like that. And you can hard code in a program 3.14159 to do the area of a circle, to do the circumference of a circle, and so many other things that you use pi for. However, what happens if they all of a sudden come out and say that, whoa, pi is no longer 3.14159. They want it to be more accurate than just that. Well, then you have to go back in and declare that in every single function that you use in every single program. So here, what I'm going to do is just talk about pi and the importance of having that, and where all you need to do is, if you want to make a change, just changing the pi. Another example could be, let's say that you have 25 students in the class and you're getting grades, and maybe you're using a for loop to get grades, or maybe using a while loop to get grades. Then you want to get the average. If you were to use a constant, you would not have to make any changes except the number of students that may change. So for instance, if you had 25 students in the class and you're using a for loop to go and get all of the students, then all of a sudden we need 27 students. Well, then that's not going to work, because you'd have to go and change 27, and then everything that used 25 would need to be changed 27. However, if you used a constant called max students, it would be automatically done every time you use it in a while loop. So we're not talking about while loops right now. That's just giving you a little bit of an appetizer for why you want to make constants your friend. And let's go look at this thing over here. So they have speed of sound is never going to change. It's always going to be 761.207, and seconds per hour is always going to be 3,600. Now, you can debate over whether seconds per hour should be an integer and 3,600 or not. However, there are some people that say there's 36.00001 seconds per hour or something similar to that. So here we got all our bases covered in here. So here's an example in here, which I'm not going to go into. I'll let you look at that on your own. And let's just look at this over here. So we have integer step size equals 5. Now remember that you should always declare your constants in uppercase, and each word should be separated by an underscore. Looking at this tells me this should be a constant. So they want to know is these are valid declarations of constants. So right off the bat, we have an issue, because yes, it's a valid declaration of an integer, but it's not a constant. So that would have to be false. Now we have constant integer step size equals 14. I don't see anything wrong with that. That would be true. So now we have total steps equals the number of steps times the step size. Well, this is a constant. This is whatever it is, and this is whatever it is. So let's go with true again. And the next one is a little bit sneaky. So the issue we have here is step size equals step size plus 1. So right off the bat, we have an issue, because if step size has not been initialized, then this is not going to really work right now. If it's a constant, we cannot change the value of a constant. It's always going to be the same. So if you initialize step size here as 14, and then you try to do this, you're going to get a compilation error that's saying value of step size cannot change. So let's go with false, and let's just see what happens. And so you're going to get a compilation error in here. So I'm going to let you work on this, and Hopefully that will be fairly easy for you. So let's go into math functions. You're going to learn about 3 math functions right now. How to do a power, how to do a square root, and how to get the absolute value of a number. If you don't remember, the absolute value is a positive number if it's positive, but if the number is negative, then it's going to be positive. So the absolute value of -3 is +3. The absolute value of +3 is +3. So here we have it, and in order to use these functions, you need to include CMath, and that will help you to add to your repertoire. And here it's talking about the square root, and the square root is just gets the square root. For instance, the square root of 9 is 3. So 3 times 3 would be 9, so the square root of 9 would be 3 in here. So we're good over here. So here are the function calls. So you have the square root of x. Now notice the single call, and that takes a double, and we'll evaluate to a double. The power takes what are we going to square, and what are we going to do. It actually doesn't have to be square. So if we want to do cubed, if we wanted to do 2 cubed, we would do power 2, comma 3. And you could be 2.0 and 3.0 because they really do take a double. And this takes power 2, the power of 2, which is 6, which would be 36. And the absolute value of x here, so minus 99.5 would be 99.5. So let's take a look at this. So the square root of 6 is going to be just plain 6. And it wants to know what is the y here. So we have the square root of 81.0. So if you remember your math, it's 9. And what is y? The power. So there we're going 2 to the 8th. So 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. And I'm not going to go all the way up, but I'm going with 256. And that's easily done. And is this a valid functions call? Well, if you take a look at the prototype for square root, it only has 1 parameter. Here they're doing 2 parameters. So the square root just is the square root. So this should not be a valid function call. So we'll put a big fat no here, see what happens. Is this a valid function call? Power of 8. Well, let's go back to our definition where it takes 2 functions. So you have 2 parameters here, x and y. This is absolutely not correct. And w and x are double values. Is this a valid function call? So I don't see anything wrong with that. So let's go with yes and see what happens. Hopefully I won't crash and burn. And we're good there. And here's what is y. So what you want to do, and this is where parentheses come in handy. So if I was writing this function, I'm going to be writing with pow, and then I'm going to put in parentheses the w and the 1.0. So if w is 3, adding 1 to it makes it 4. Raising it to the power of 2 should be 16. So there we go. So I'm going to allow you to look at this thing and work on that, as well as this itself here in here. And here is the square root of something. So we have x squared plus y squared. Now I know they're talking about the Pythagorean theorem, and the Pythagorean theorem is the square root of the sum of the sides equals the square of the hypotenuse. So if you don't have to worry about all that. So we're looking at x being the square root of the sum of y squared and z squared. So we want to do these statements in order. So let's take a look at what they have. So we have temp1 x, so x is not having the power. So we need to find y squared and we need to find z squared. So here is y squared right here. So we're doing temp1 is going to be y squared over here. So the next one we're going to need for z. So we're going to do temp2 equals z squared. So now this is basically the square root of temp1 plus temp2. So let's look and see if any of them have that. So x is going to be the square root. Now this wouldn't be right because it's going to do the square root of temp, and this would be then adding temp 2. So I'm going to go with the sum of temp 1 and temp 2, which is the sum of this here, and then get the square root. All right, let's see if we can break this down. So what we have is 2 to the power of x to the y plus 1. So remember, when your exponents is, you're going to add things to make it in here. So the first thing is x to the y is power of x to the y. But remember, since we're doing x to the y plus 1, we want to do 2 to the power of x to the y and then plus 1 in there. So that sounds a little bit confusing in there, but just remember that if you use parentheses, it makes it a little bit easier. So ultimately, we have to raise 2 to x to the y to whatever that is plus 1. That's our final power. So here is 2, and then we're doing the power of x to the y, whatever that is, and then we're adding 1 to it. So our ultimate would be this one over here. And maybe we'll do 1 here. Type the ending of the value of z. So basically, this is telling us we want to raise 2 to something. So let's calculate 2 to the third, which is 8 in here. So 2 to the 2 is 4, 2 to the third. So what we need to do is raise 2 to the power of 8. So I believe that will be from memory 256. Let's try it. If not, we'll find out real fast. And it is. So the rest I want you to do on your own. And then we're going to talk about, the C math is what we've already talked about. And the standard library over here offers a lot of extra functions that are in there. One of them is rand. There are different ways to get random functions in here. So there's a whole huge library from the standard library in here. But at this point in time, we're not going to go into that. For CMath, we'll do everything that you need right now as far as power functions, as far as square root, and as far as the absolute value. So this was a short video. I hope these videos are helpful. I ask that you submit comments, let me know, and if there's any way they can be improved, please let me know. If there's a specific video that you would like, then please feel free to let me know and I will make it. And I will be showing you my YouTube channel, which has approximately 75 C++ tutorials on all kinds of different things. So I'm hoping that you find that helpful. So that's it for this video. Have a wonderful, wonderful day.